Greetings and salutations. Thank you for checking out the video. It is most appreciated. I hope it finds you doing well wherever you are in the world. If you like what you see, give it a like. It helps. It'll put this video in front of a lot of new people to Linux, and it will help my channel. Also, consider subscribing if this is something that you're into. There will be a lot more videos like this coming up. I want to say thank you to everybody who responded to my last video. I put a video up talking about changes in my life and the fact that I was going to be dedicating a lot more time to the YouTube channel here, and you guys said that you wanted to see videos like this. So we're going to do a lot more videos like this in the future. This particular video, we're going to talk about backing up personal data, Linux backup strategies. And as I was noodling on how to put this together, I realized that just about every application that I was looking at to show you guys used Rsync at its heart. Rsync is a very powerful command in the Linux world, and it's one of my favorites. I've worked on a lot of different projects over the years that involved backup plans, backup strategies, system snapshots where you can restore the system. We'll talk about that later in the video. And they all used Rsync at their heart, so that's why it's getting star status here. We're going to start out simple and we're going to work our way up. We're going to start out with really basic concepts, and then we're going to get more complicated as the video goes on. This is not a how-to video. I'm going to present you with different ideas and concepts and run through them and let you know my opinions on backups and why I say this is how it should be done. I mean, I realize that there are different schools of thought on this, and you are more than welcome to put your opinion down in the comments. If you're new to Linux, I'm really glad you're here. If you're a novice, this is going to introduce you to a lot of very cool basic concepts. If you're an intermediate user, I'm sure there's going to be things here for you to learn. And if you are a longtime Linux user who can program in 5 different languages and you're an admin and whatever, you can point at the screen and laugh at me, and you can get in the comments and talk about all the mistakes I'm going to make. Feel free. It just boosts engagement. It's fine with me. So let's start out with some really basic concepts here. First of all, the only way to ensure data integrity is to maintain multiple copies in different locations. I wanted to put that right up front, right up top, in all caps with a bang at the end, because it is so true. I have worked with many people through the years that have had some failure on their system, and either they didn't back it up properly, they didn't maintain a backup at all, or their backup solution ended up not working, and they ended up losing some or all of their data and had to start from scratch. That is not a situation that you want to be in. And of course, we're assuming here that you have personal data that you're keeping on a local machine. A lot of people these days, they stick everything up in the cloud. This might not be as important to you, but still, you should have some sort of backup. I mean, even if it's just for the settings that you have on your machine and whatever projects you happen to be working on currently, you need to have another copy somewhere, or basically you don't have it. A lot of businesses say that if you have one copy of a file living on one local machine on the network and it is not backed up, then it doesn't exist. So keep that in mind. A backup solution, when you're looking at different kinds of software or strategies to do this, you need to keep one thing in mind right up front. You have to be able to get that data back. And I am not a fan of any solution that requires you to use proprietary software to access that data, because there are situations where you might not be able to get access to that software. If it's an online service where you're uploading your data, what if you can't log into that account? You can't get it. It's not there. Years ago, I worked with a fella who had a computer with a single hard drive in it, and that drive crashed. And he said, "Oh, it's really no big deal. I've been backing all this stuff up. If you could just help me to reload the system, we'll rebuild it." Okay. Well, when we got the system rebuilt. We put a new hard drive in it, and we installed. At that time, we were working with Windows XP. We had that in the system. And I said, okay, now where's your backup software? Let's install it. He did not have the install media anymore. Couldn't find it. Not only that, we get online and you can't download the software. Basically, it doesn't exist anymore. So he had an external drive that he had been using to faithfully back up that machine for at least 2 or 3 years, and he couldn't use it because it was all proprietary and there was no way into it. So I don't like solutions like that. They scare me. So when you're looking at backup solutions, be sure and think about how you're going to get a hold of the data to restore it. Which leads me to the first solution I have listed under here, and first strategy, which really isn't a backup strategy at all. I have talked to many people through the years who want to use this as their backup. And it's clunky. It is something that creates very large files, especially if you have a lot of data on the system. And large files are prone to corrupting. All you have to do is flip a couple of bits the wrong way, and then all of a sudden all the data goes away. And it's not super reliable when it comes to restoring things. And we're talking about ghosting a system or making a full system image. The name ghosting comes from software that was popular 25, 30 years ago from Norton. It was Norton Ghost, and it was a piece of software that would let you copy all of the data that was on your present hard drive over to another drive and then install that drive into the system, and it could also create image files. And a lot of admins would talk about ghosting a system. They built a server and they ghosted it back in the day. And so that's where that comes from. And what you're doing essentially is copying an entire system's data set into an image file. So that file contains the bootloader, the operating system. It contains all of the installed applications, all of the configuration for those applications, plus your personal data and the settings. And a lot of these image files also back up the zeros that are not being used on the file system partition on the drive. So it creates huge files. Unless you're talking about a very small system, if you're doing this with like a Raspberry Pi and the whole system is 10 or 11 gigabytes, sure, this will work. But if it's a regular size system that has quite a bit of data, it gets dicey. Plus, my experience playing with these sorts of things is that they're not terribly reliable about restoring things. The open source alternative to Ghost is, of course, Clonezilla. It's been around for years. Clonezilla is a very useful tool, especially if you want to upgrade a hard drive or something like that. But you have to be very careful as you go along to be able to get a bootable system when you're done. And if you make a mistake and you create the wrong kind of image file, you're stuck. Now, in a situation where you are copying everything off of one drive so you can replace it and then putting in another, that's not such a big deal, because if it doesn't work, then you just put that original drive back in, you try again and get it right, and then it works. But if you're in a situation where you've had a catastrophic failure and all you have is this image file, and for whatever reason it can't be restored, we're back to where we were with having the proprietary backup, and it won't work at all. So I don't consider this to be a great backup solution. I think a lot of people think this is because Windows these days encourages you to create a restore disk. When you install the system, it will tell you, let's create a restore disk, and you put it on some sort of plug-in drive like a USB stick, and then you can reboot the system later in an emergency if something goes bad, and you can restore it. I don't know how much of the system gets restored and whether that has anything to do with your personal data or not, because I don't work with Windows on a daily basis. But that's definitely not a backup solution. That's an emergency restore system that Windows has. And by the way, if you do have Windows machines and you've done that and you're using flash memory based SSDs to store that, you might want to do that about once every 6 months or so, because flash memory sitting on a shelf will actually start to fade after a while. You'll start to lose that data. That's the same even with a high-end SSD. So you really shouldn't use SSDs for long-term backup. As a matter of fact, I always use spinning drives. I really like the Western Digital Elemental drives. You can find them just about at any retailer, and they're relatively inexpensive. They're very robust. I've had very good luck with them, and you can get pretty large sizes because you have a little spinning drive in there, and they work with just about any kind of computer. It's USB 3 compatible, and you just plug it in. If it's USB 2, it rolls back to that. It works just fine. Love those little drives. That's not an endorsement. It's just what I happen to use. So anyway, let's talk about some of the different ideas about backing data up beyond the full system image, which I really don't consider to be a really good backup solution. One of the main reasons that I don't think that is a great solution is because it's not necessary. Linux is so easy to reinstall. Even if you had to rebuild your system from scratch, if you have your personal data and you have the settings from your system and you know where to put them back once you install it, and you know what programs to install once you get there, it really doesn't take that long to completely rebuild a system if you have a good backup. And of course, people that are new to Linux don't understand that. They don't have a lot of experience redoing a system, but if you've been using Linux for years like I have, I don't think twice about it. If I wanted to change the operating system on this computer, I'd just do it. This computer is currently running Ubuntu 24.04, and coming up here shortly, I plan to move to Linux Mint Debian Edition 7. I'm not the slightest bit worried about it. It'll take a couple hours. Boom, done. So, different backup strategies. Local backup. That would mean that you just copy the data within the same machine. That could be on the same hard drive, or you could have two different hard drives in the machine, and you could have like a partition there that's just for backups. You could even put a script on the machine that would run on a daily basis that would go look for changes and do incremental backups if you wanted to. This really isn't a long-term backup solution, though, because if something kills that machine and ends up killing the hard drives in that machine, it's all gone. So this isn't something that you should do and think, okay, well, I'm backed up and I'm safe, because you're not. Because things can happen to computers. Power supplies can go crazy and they can fry drives, and you can have lightning strikes. Somebody could steal it. All kinds of stuff. So this is good in a situation where you're working on a project and you have created a lot of data files and you want to keep a backup just in case you do something stupid like screw up your work, you trash something, or you end up deleting a bunch of stuff. You have a way to get to that. And if you're working with deep configuration files, always create a backup file somewhere. Make a copy of it just in case you mess it up, so you can put it back to the way it was and figure out what you did wrong. So that would be a local backup. The next thing up would be to have an online backup of some sort, and this would mean that you could have a server running on your network. This just means another machine that you can send files to. It could be something as simple as just another machine running Linux that doesn't do anything but serve files. I have one of those. You could also have one of those more expensive NAS systems, NAS, Network Area Storage, where some of those systems are very complicated. They'll have RAID systems in them and several hard drive arrays and whatnot. A RAID system does not constitute a backup. RAID simply means that it makes the storage device more robust. But if something should happen to that storage device, just like a computer, and it destroys all those drives, all that data goes away. The nice thing about a RAID system is a lot of the times you can store a lot of data, and if one of the drives fails, there's usually a way to be able to replace that drive and rebuild it depending on the system. But RAID does not mean a backup. It just means a more robust storage device. Now, if you have an online backup and you're doing it somewhere in the cloud, that becomes a little bit more secure because now you're sending that data off-site somewhere. And of course, we loop back around to the original concept if you have to be able to get to it to restore the data. If you yourself have a machine that you have rented on a server somewhere, and you can do this, you can rent a machine and attach a bunch of storage to it, and you pay a monthly fee to run that server somewhere, that could be a pretty cool way to stick your personal data up in the cloud. Now, I'm not talking about Google Drive or OneDrive here. Those are very useful tools, usually for projects. If you need to be able to access files from different computers, it makes it super easy to do because you just log into your account and it's there. But I have a really hard time putting personal data up on one of those services because if it's on the internet and if Google has access to it and if Microsoft has access to it, then that means probably at some point that everybody will have access to it. So, not a big fan of that. Now, a server that you maintain on your own, that's a different story. That's actually dark web right there. That's the definition of the dark web. That would be something that you have access to that nobody else does. It's not public. So, but once again, you're dealing with a situation there where you have to be able to log into that to get to that data. And you'll have to noodle on that one for yourself. I wouldn't use that as my only backup strategy. I would not use some sort of service. They used to have a lot of ads for these sort of online backup services. I would never trust that. I'd be afraid that I'd lose the account or wouldn't be able to log in or somebody would hack it and then you'd lose your stuff. Now, the next level of security would be an offline backup, and this is my main backup strategy right here. I do online backups. I have a file server that I back up to, and plus, on my network, I have 3 machines now, currently, that have an account on them that's mine. And I will sync those machines up from my main machine here. And so about once a week or so, I will sync everything so that those machines, when I sit down at them, will have the same data that's on this machine. And in an emergency type situation, that means that I have access to a machine that has all of my data that's relatively up to date. It's right there. And the next step that I do is to create an offline backup, which is copy all of that data to removable storage. In my case, as I said, I use the Western Digital Elemental drive, and I can put data from several different machines on this drive, and I have another drive which is a backup of that drive, and I will put them in plastic bags that are sealable, like a zip top bag. And the reason why I do that is in case the roof falls in or something and it gets wet, that drive stays dry, and I'll be able to hopefully be able to find it and restore it. I also have offline backup as well. So, online backup and offsite, because not only do I have access to it online, I also know the person where they have this in their system, and they have backups of that system as well. So if worst came to worst and there was some disaster where my house was completely destroyed and I lost all of my computers and all the disks, I would still have access to a lot of my data. So that's an off-site backup, which is the last thing on the list here, and that's copying data to removable media and sending it physically off-site for safekeeping. In my case, I got an SSD drive and copied what I wanted to have saved and sent it to my friend, who immediately copied that data from that drive and put it in one of his servers locally, and so there's one backup there. He put that drive up. It's an SSD, so it'll fade after 6 months. I'm not really worried about that because once it's on the system, And I can use the SSH command to get into that system. He gives me access. He created an account for me, and I can update that data every now and again. So it's a very cool little arrangement. And if he ever says to me, well, I don't want to do this anymore, I don't like you, that's no big deal. I'll just say delete the stuff, and I'll send a drive to another friend somewhere else and just say, here, hang on to this. Some people even buy tape drives and do that, which is, yes, that's a viable storage system for data, and it's passive. Unlike a hard drive or an SSD or a USB stick or anything, or an SD card, that sort of a thing right there, tape, you can put it up on the shelf, and as long as it's stored well, it should hold that data for many, 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 many years to come. That's if you have really, really important data, you might want to do that. So when you're thinking about backing up, really the thing to do is to have not one of these solutions, but a bunch of them. Before I introduce you to Rsync, which is really the star of this show, I'd like to take a moment and review some basics about the Linux file system and how it stores personal data and settings and where you can find those, okay? So what I want to do is I'm going to list the root directory on my Ubuntu system here that we're recording this video on. And you will see we have some files, and we have some directories here, and some links, and all kinds of good stuff. And we can tell what is what if we do ls l. That's what I want to do. Oh, we need to tell it what directory we're working in. So /. That's the root directory. So here we are. We're in the root directory. We're looking at the long listing for that. And you can see here by looking over to the far left that anything with a D is a directory. And anything that just starts out with a bunch of gobbledygook there, that's a file. And these are the permissions over here that you're looking at. This is who owns the directory, and pretty much everything in here is owned by root. Okay? And this is the size of the file or directory. Directories usually always come up to be just 4096, which is one cluster on the drive. This is the date, and then finally over here we have the name. The top thing that you'll see here is a link. It starts with an L over here, and you'll see that it's linking a directory called Ben to user/Ben. So that's what that is. So what is the difference between a directory and a file? What are those two things? A file is where some sort of data is stored in a nice, neat little collection. And a file can represent a document. It could be plain text, or it could be a document with all kinds of different formatting, as in something that you would use in LibreOffice or any kind of word processor. You can have a file that contains digital audio, like a WAV file or a FLAC or an MP3. It could contain picture data, so therefore it's a picture. It's just a container that has data that pertains to whatever we call the file. A directory is nothing more than a file that has a bunch of file names in it. The reason why the root directory on any computer system doesn't have a name and you can't call it something is because there is no directory above it to contain its name. That's why in Linux and Unix it's represented by a /, and that's it. So, very simple concept here. Now, a directory, a file which contains file names for other files, can contain other directories as well. So it goes on and on and on. So the root directory that we're seeing here can contain all of these directories and all of these files, and then each one of these directories has more files in it. And that's basic stuff, but it helps you to understand exactly how when we start talking about directories and file system paths and things like that, that's what we're talking about. A path is nothing more than the way you get from the root directory to whatever file or directory you want to work with. And we'll talk about that a little bit more in depth here in just a moment. What I really want to show you here is that we have a directory called etc. This is a system directory that is full of system settings. When you set up a program or set up your network or whatever, this is where they go. They go into here. Anything that is a setting for the entire system will go into etc. So if we want to back up our settings, that's a directory that we probably ought to back up, is etc. Now, the other directory that we're interested in here is home, the home directory, and that is where all of the user data for all the users on the system is stored. This is where it goes. So each user account should have a directory in there, and in that directory should be all of their personal data. They have 100% access to everything that is created within that directory. So they own what's in that directory. You'll notice here that when we look at this section in this long listing, it says root and root. All of this is owned by root. Well, what does that mean? It means that the owner of the directory is root, and it belongs to a group called root as well. Now that's pretty deep, and it can be different. You can have a file that's owned by a particular user, and it belongs to a group. Groups are an old school way of keeping security within a great big mainframe computer that has a lot of people logging into it. You create a group, and then a group of people working on that project will have access to the files that are owned by that group. And within that group, files can be opened by the individual, opened and worked on by the individual users that create them as well. So that's where this comes from. Now, things get a little bit different if I get into the home directory. So what I'm going to do is clear the screen, and I'm using Control L to do that. That works in most terminals. Or you can just type in the word clear if you want to, and that'll do exactly the same thing. I alternate back and forth because I'm very old school. So what we want to do is we're going to change directory, and I want to go into the home directory. So now I'm in home. You'll see that the system shows me that I'm in home. And it's a good time here to talk about being somewhere in the system, because Unix and Linux is very much into this idea of you are somewhere in the system when you're logged in. Even if you're running graphical things, you are usually in your own home directory. And there are two ways to usually get to a file from anywhere on the system. The first thing is a relative path. Okay? So a relative path means how to get to the file from where you are, and that file has to be in directories that are either in the directory that you're currently in or below it. Now, this is such an important concept. There's actually a command that you can use, present working directory, PWD, that will show you what directory I'm in. This will give me the path to that directory. That shows me the absolute path. So that is very important when we are generating commands telling the system where to find things. Usually we want to use some sort of absolute path, starting at the root directory and working its way down. Okay? So we're here, and I'm going to run ls, and you're going to see we have two different files here, because on my system, the home directory actually lives in its own partition on the drive. It is separated into a separate partition from the root directory. And by the way, don't get the root directory confused with the root user. In case I hadn't mentioned that earlier, the root user on a Unix Linux system is the administrator. The root directory is the base of the file system to which everything else is attached. So you see here that there is a directory called Joe. This would be my personal home directory on this machine. And now if we used the long argument on the ls command, you'll see that we're getting a little bit of a different output here. You see, there's the directory called Joe right here, and that directory is owned by me. And this other directory, lost and found, that's actually something that works with the ext4 file system. In case there's a file corruption of some sort, it will put things into this directory it doesn't know what to do with. 99.99999% of the time, this is an empty directory on your system. But it's created when you create the partition in ext4. So it's owned by root. So anyway, you'll see that if I go into this directory, so now cd Joe, it stopped telling me where I was, because when you're in your own home directory, it doesn't bother. This is where you're starting out, because this is your home on the system. But if I do present work directory, you see I get that directory telling me that I'm now in Joe. Should I happen to go into the music directory, for instance, okay, now it's telling me I'm in music, and we have this little slashy thing here, this little tilde. The tilde represents the home directory. So when you're writing commands, you can just use the tilde. And if I list what's in here, then it just has more directories for music that I have in this particular directory. Let's do that with the long option. You'll notice that we have a bunch of directories. They're all owned by me. If it's owned by me, and the system has created a group called Joe, this is the group and the owner right here, that means that I can write and delete and do whatever I want with these files. So these are my personal files that are in my directory. Here's a trick for you. If you just type in cd, it'll automatically take you to your root directory. Or if you want to be really pedantic about it, you can use the tilde. It'll do the same thing. So all of my personal everything is in this directory. Let's do ls, and we're going to show all the files in the directory now by using the A. And you'll see now, instead of just seeing desktop documents, downloads, see, like if I just do a regular ls here, let's do that. You see all I get are the directories, but if I do ls A, let me go ahead and clear this so this is a little less confusing. You'll see that we have all kinds of stuff in here. There's a file called face. That's my avatar. Let's see what else we got here. We've got tag tool. This is a program that I have on the machine called tag tool. So there's the configuration file for that. And then you'll also notice that we have .cache, that's where we're caching a lot of things. .config holds configuration files for things. We have .local. .local is a directory that holds a lot of configuration files as well. Plus you can also put executable files in there in certain places. It's a lot to it. This is all the stuff that we need to save. This is our personal data. So we need to make sure we back that up, and then we do. Let's go to etc, and we'll list that. This is all of the configuration files for the entire system. It would be nice to have copies of this as well. Now, you may not be a super advanced user, and you might not know what you're looking at here, but if you hang on to a copy, and for some reason you have to restore your system, and you get help from somebody who's more advanced, this can be very useful, because you could just put the configuration files back the way they were, and that's the end of that. So that's just a quick look at the basic file system and how it works in Linux. Just a refresher for those of you who don't know. So we've learned that basically we're worried about etc and we're worried about home. And the rest of the system can be restored quite easily with a reinstall later. And a piece of software that I'm going to show you in a little while, this separation between the system and the local user is very important as to how it works. So we can go ahead and clear the screen. I'll type it this time just to show that it works. And I'll go back to the home directory because that's where we need to be. So let's talk about the good old rsync command. What does it do? Well, it moves. Well, if you haven't hit the caps lock button, that ain't going to work. Let's look at the manual page, and we'll talk a little bit about it, and then I'll show you some examples. So Rsync, it says, is a fast, versatile, remote and local file copying tool. So what does this thing do? It moves data around. You may be familiar with the CP command. You may even know about SCP, which is secure copy that you do over a network. What you're doing with Rsync is way more advanced. It moves big chunks of data from here to there. So you can look at the man page anytime you want to. I'm going to show you some basic Rsync commands. I'm going to actually just get some stuff to move around on the system here, and we will we'll see see how it works. That's what I was trying to say. So the first thing we need to do is create something to play with. So we're going to make a directory, make dir, and we're going to call it playground. Didn't misspell anything? That's marvelous. And we're going to make that right now. This is in my home directory, and we're going to cd into playground. Not with the space, please. Don't worry, I'll get it right sooner or later. There we go. Trying to think and type at the same time is difficult. And I haven't done videos like this in a long time, so go ahead and giggle. Have fun. It's all right. So we have an empty directory here. There's nothing in it. So we need to create some files, and I'm just going to create some dumb files to play with here, and we'll call them file 1, file 2, file 3, and file 4. So that should create a bunch of files. There they are. We have our files. And let's put another directory in here called, I don't know, more files. That's what I want to call it. So we'll make dir more files. Here you go. Okay, so ls, and we'll cd into more files, like so. And we're going to go up here and touch some more files. Let's do this. I should have it. There we go. Boom. I just put a whole bunch of files in there. ls. So we have a whole bunch of files and stuff to play with. Let's go back to the home directory and get out of there. We know it's there. So Rsync, in its most basic form, will let me make a copy of this directory and put it somewhere else. So we're going to make this super easy. And we go rsync, and we're going to use A, which means that we archive the files. The attributes remain exactly the same. V is verbal, which means it shows us what we're doing. And one more step is to put a P there. That will give us progress. It'll show us how long it's taking to move the files. And that's just so you can see. Another option would be the delete option. Now the delete option, what it will do is not only will it move files from one place to the next, now we're getting to an area where it's going to make an exact copy of the original directory. So if we go from directory A to directory B, and there are extra files in directory B that were not in A, they will go away. So it makes an exact copy. Now this is why this is powerful for backups. So that is the rsync command, and then we just tell it our source and destination. So in this case, we're going to do playground, and since it's already here, all I have to do is hit the tab key, and the system will check to see if it'll fill it. That's what I'm doing. So if you see all that text appear, that's how I'm doing it. I'm using the autofill system, fill system. Fill system is what I said, but fill system. And you notice that it automatically puts this extra slash at the end. This is important. The slash at the end will tell the system to put everything in this directory into whatever directory I say next. Okay? If I do not have that there, then it'll move the whole directory to the destination directory. So in this case, our destination directory is, we're going to say play backup. That's our directory. Now, I'm going to put a slash. What that tells Rsync to do is to take all of the data that's in playground, move the whole directory plus the data, and put it in play backup. So let's go ahead and turn this loose and see what happens. And there you go. Now you notice we didn't have any progress come up because there's no data. All of this is empty. These are just file names that we're talking about. It lists everything that it moved. And so now if we cd into the play backup directory, okay, and we're going to list what's in there, you'll see now we have playground in there. Just in case, let's move that to the top of the screen, and we'll do that one more time. Now we have playground. This is an exact copy of playground. Now let's go into play backup and let us have some do something interesting here. Let's go to we're going to cd in to playground. Now remember, we're in the copy here. We're not. This is not the original. And I'm going to list it, and I'm going to touch. And we're going to call this file 5. Now remember, there's only 4 files in the original, so we'll put that in there. There it is. Okay. Now I'm going to go back to the original directory. So get to my home directory here. Actually, I could have showed you something cool there. Let me go back to where I was so I can show you something cool. So we're going to cd into play play backup. All right, we're going to go back to where we were. We're now in that directory where we were just a few moments ago. And I'm going to use a different thing. We're going to use pushd, one of my favorite commands in Linux. What we're going to do is we're going to push our current directory on the memory stack. And we're going to go to a new directory. And to get there, I'm going to use an absolute path. I need to tell the system exactly where we're going. We are going to my home directory, and then we're going to go to playground. Okay, so we'll go ahead and do that. Now we have jumped to playground, and it told me that we have moved there. Now watch this. Let's list storage there. I'm going to touch file 3 again. What does this do? Changes the date. It makes the system think that this file has been updated in some way. So that's what we want to do. So now that we have created our backup, let me get out of here, and we're going to popd. Popd puts me right back where I was. So very cool little feature that you can jump around the system using that thing. Now I want to get back to my home directory. And let's see, what I want to do is I want to run that rsync command again. And to get it, I'm just going to scroll up using the up arrow until I see it, because that's a lot of typing, so we want to get back to it. So now we're going to use this to do a backup again, and we're going to see what we get. Well, what did we get? First of all, it said it was sending the incremental file list. What that is doing is it's sending the changes to the command. It's checking what's in the other directory, it's seeing what has changed, and then it prepares to do those changes. So the first thing that it did was delete file 5, because as you recall, we created that in our backup directory, but it doesn't exist in the original directory. And then it updated file 3 with the new access date, because when that access date changes, the system says, okay, this file has changed and it needs to be backed up. Some of you are probably already figuring out here that what is really cool about what just happened is that we didn't have to copy everything again to make that work. We copied all of the data once, and then a little bit later, when things had changed, we synced the data from one directory to another, only sending the changes. And it goes on deeper than that. It's not just sending different files, just the changed files, but over a network, if it's a very large file, Rsync is smart enough to send a delta file to the other end of the network. In other words, it doesn't send the entire file again, it sends the changes to that file. It figures that out, and it'll send a diff file to the other side, and then that file will be updated. It'll be patched, and that's how that works. That is very useful when you're moving a lot of data and you have a lot of big files, and let's say the only thing that changes is the access date or something like that. Now, if you rename a file, it will delete the file in the backup in the destination, and it will send that file over again. But if the name remains the same, but just some attribute of the file changes, it'll only send the changes. It makes it super powerful. Okay, that's great. I can move directories around on my local system like that, and Rsync does a wonderful job of that. And as you can see, if you can take this little file here that we just, this little command, we put it into a little stub script, then we could change it to where we could just say, call the script sync, right? And, well, not sync, that's a Linux command, but you'd have to put something else to it, like, sync this machine, sync this directory. It'll run that in the background. Boom, we're doing it. It's automated, and it's super quick. You can also, of course, set the machine up to do it automatically over a network. If your file server is always up, you could have the machine periodically update the files. Now, I choose not to do that automatically. I like to do that manually. I like to be able to watch it, and I know it's done, because things run in the background and then they break, and then you don't know they're working, if they just stop working for some reason, and then you end up, well, I haven't really done a backup in forever now, have I? So let's talk about using this over a network, and we're taking a big step up here. If you are not familiar with SSH, this is the background tool that we're using to make this happen. SSH is the Secure Shell Protocol. It lets you log into a remote system on the network, or if you have access to it over the internet, you can log into a system. And in order to do that, you have to have hostname resolution set up on your router. Most ISP routers don't do that, so I use a very simple approach, and I use the IP address of the machine on the local network. And then I have a little shorter thing that I have done. I've written a stub that lets me just put in the last two numbers. So that's you're going to see me use that, and I'll show you the stubs later in the video. I'll show you what those commands look like, because everybody always goes, ooh, how does that work? And why do you do it that way? And yes, I do know that there's a way these days that you can have the systems announce their host names. I'm so used to doing this way that I just continue to do it because I'm an old curmudgeon and I've been doing it like this for years. So let's send some data to the file server. And what we're going to do is we're going to issue the rsync command again. Okay. And I'm going to use the same AVP. Really don't need progress because there's nothing in there, but we'll put it in there anyway. You're not going to see any progress come up because there's no data. We're just sending empty directories and stuff over. We're going to activate delete again. Although we really don't need it here, we could omit this, but just for the sake of completeness, I'm going to go ahead and put that in there. And by the way, if that makes you nervous, just don't use it. But just realize that your directory on the other end is going to start filling up with all of the files you delete on the other. And if that's what you're desiring, that's fine. So we're going to go ahead and send playground. Okay, and I'm going to take that off again. Actually, this time we'll do a one-on-one. We'll do that. And we're going to use, okay, let me explain what I'm doing here. If you have an SSH account on that machine, and it's the same as the account that you're doing it from with the same permissions, in this case, both of the accounts are named Joe, then all I have to do is put in the IP address to that other machine or the host name, and it'll go straight to it. If you are logging into another account that isn't your name, you're like have access to because you're doing this, you're transferring data from one account to another, then you have to put it in. I'll take the long way here just to show you. So it would be Joe at, I don't have to do this, 192.168.0.12. That's my file server. The home directory is represented by a colon in this particular instance. And so what I'm going to do is I'm just going to tell this, hey, take this and stick it in my home directory. So I put that's all I got to do. Here we go. And it's going to go find the system. This might take a second. There it goes. And it's told me that it has put that directory over there. Now, how are we going to know that? We're going to pull up another terminal. Make this a little bit bigger so it's easy for everybody to see. And we're going to use my stub. Stop turning on the caps key, man. Turn on my stub here. Use my... Go into 12. I'm actually going to log. What did I do wrong now? Pay attention, man. There we go. Now this is going to let me log into that file server. Now we're in. So if I list what's in the home directory here, do I see playground? Yes, I do. So we have moved this across the network. Now, if I go here, let's do the same thing we did before. So I'm going to clear this CD into playground, and I'm just being very pedantic here just so you see this work. We'll list the storage. You see we have the files. I'm going to add another file just like I did before. We'll call this one file 5, right? And we'll even do, let's do something here. We're going to delete. Let's see, where am I? Let's list here. See what I'm looking at. So we will remove, not delete. I think Microsoft is Dell, right? DEL to get rid of a file. This is Linux. This is how this works. We're going to do file 2. We're just going to take it out of there. Just making changes on this end. Oh, no space. Dummy. Okay. So now we're going to CD I'll come back over here. This is the local machine. This is the original. So this is, just so you're not confused, this is the file server, which is named Teensy, and this is the local machine that we're working from. So we're going to run that command one more time. We're going to see what it does. We're doing exactly the same thing again. Now it takes a little while over the network. See, it calculated all that stuff, and now it has deleted the files, and of course I didn't change any files, but you'll see what it did there. So that's basically how Rsync does what it does. It is an extraordinarily powerful command, and if you're not, I'm sure that some of you out there that have really not looked into this, you might have known about this and you didn't know exactly how it worked and how easy it was to use. I'm sure that you're out there right now going, I can do all kinds of stuff, because that's about my reaction when I started to learn about that. No, I don't want to just close the directory. I'd like to exit properly, please. Thank you. Okay, now I logged out the way I'm supposed to. Now close the directory. Thank you. Made me mad. Okay, so we have looked at the basics of Rsync, and what I want to look at now is ways to apply this. And for those of you who watched that section and went, well, I'll never remember all those commands and I'd have to go look all that up, I'm going to show you something that you might find very cool, because this is a fun tool. I don't think I have it on this machine. So let's see. Let's go ahead and install it. And we will go ahead and grab that. Okay, yes, that's fine. It's not installed on this machine. I don't use this very often because I usually use it from the command line when I'm using Rsync, because it's second nature to me. But if you want to use this occasionally, like you're going to do backups every now and again somewhere, this might be the way to go. So we're going to go ahead and open up the application. And this is it. What this is a graphic front end to Grsync. So we can do the same thing here, but we're going to do it by typing the destinations in here. Now this is really cool for external hard drives. I do not have a great deal of experience using Grsync over a network, so I'm not even going to attempt to do that. But you basically type in your destination, and what's cool is that you can just open your destination. So let's go in here. Let's see. Our source is going to be playground, right? And we're going to open that. That's fine. And then we're going to open our destination. Play back up. Okay, so that's put that in there now. All right. And then we're going to, let's see, we want to preserve time. We want to preserve owner. Preserved permissions and preserve group. So we're making exact copies of these files. Delete on destination. So that would be the same as the delete that I put in up here in the terminal. Let's see. Don't leave the file system. Show transfer progress. Windows compatibility. If you're going to be backing up files to an NTFS drive, that'll turn that on here. We can also skip newer, which means that I would guess that would be that things newer in the destination drive aren't removed. Of course, we've already established that we don't want to do it that way. We have advanced options here. You can explore this if you want to. And we got extra options. Very cool. We have our working directory here. or there's a profile here. That's what this is. We could save that if we wanted to. So once we have this going, it's been a long time since I've actually done this. Let's see. Make a full run. Let's do a run. Now remember these guys too, guys. We want to put that into here. So you have to remember your slashes. That applies even in Grsync. So let's do an experimental run, see if it'll work. And that's what it says it's going to do. Why is it deleting? Okay, let's see what we did there. Okay, see, I got that wrong. This is why this is important. Like that. Now do it. And it says nothing's changed, pretty much. All right. And, of course, we'd have to make a change to make it do anything, but there you go. You get the idea. So that's the first tool I wanted to show you was Grsync. So if you wanted to do like really, really super basic backup stuff, you could do it that way. You could use Grsync. It's kind of a fun little tool, especially when you're trying to do something complicated. You can do that run without actually making any changes like I just did, because I'm not terribly used to using that. It's been a long time. But that's available in the repositories for just about every Linux distribution out there. It's called Grsync. So the next application that I want to show you is one that I highly recommend that you install on your Linux system, regardless of what kind of system it is, if you have it available to you. And that is a piece of software called Timeshift. And Timeshift, it is capable of doing a backup, like a whole system backup, but it's really not terribly good at it. If you can make it work, like you have a system that, as I said, that has a small bit of data on it, and you have a backup drive that's rather large, you might be able to do this. You might be able to configure this to do that. So we're looking at Timeshift, and you can see that it creates snapshots of the operating system. So let's just walk through the settings here. We'll go into the settings, and there's a wizard, and we are going to use Rsync, which means that we are creating a backup somewhere on our local drive. Now, I know you're saying that's not really a backup, is it? Well, we're okay with this because what we're creating with this is system snapshots. Let's say that I'm sitting here and I'm playing around and I install some software that breaks the system, or I bork something up. What this will let me do is roll back to a known good state. This does not affect my personal data. This doesn't affect what's going on in my home directory. So the letter I wrote this morning, or whatever, the picture I took that I saved to my local drive in my home directory, is not going to be affected. It's just the system. If you have a system that's using BTRFS, I've heard that called ButterFS and BetterFS, whatever works for you is fine with me. And this software will do a snapshot within the file system itself, which is something that is possible with ButterFS and ZFS and more advanced file systems for Linux. We're not worried about that today. So the first thing that we do is choose a location for our backup, and in this case I have chosen the root, the actual system partition. Remember, on this system the hard drive has a root partition, and then it has a home partition that contains all the personal data. So we're putting this into the original partition. The reason why we're doing that is because there's a trick that Rsync pulls to minimize taking up space on the drive, and it's more efficient if it's done this way. And I'll talk about that in just a moment. So then the next thing that we will set is what kind of backup we want. I have mine set up to do 2 monthly backups, which means that there's always a backup that's on the drive that's more than a month old, and 3 dailies. So it will save the last 3 days, and this will happen once a day. This runs in the background. It's a cron job that runs in the background, and it takes a snapshot of the operating system. It's not your local data. So essentially what we're telling it here with this screen is that we want to exclude the my home directory and the root home directory, which is, remember when we were looking earlier at the listing for the root directory, we saw a root folder or directory in there. That is the home directory for the root user. The root user, by the way, on Debian, I was going to say Debian, but Debian actually, I think you create a root user still. But on Ubuntu and Linux Mint and many other distributions, the root user account is actually closed. It's not there. You don't have a password and the account is locked. And that's an extra secure step because if there's no root user, I can't really crack that account. And so administrative users on those systems will use sudo to do that, or sudo, pronounced properly. Substitute user do is the command, and that's why in Ubuntu you don't really log in as the root user. But in this case, we don't want to modify anything in the home directory, which on this machine is in a different partition. So it ignores that completely. All right. So we also have filters here where none of this, we're not doing it. And then the last is this miscellaneous, which is the date format, which I don't mess with. If you want to mess with that, you can do that if you want to. So this will run, like I said, once per day and create a backup. So if I run into a situation where I bork up the computer to restore it, it's really super simple. You bring up this application. You have to do this with root privileges anyway. You will select one of these known good snapshots, and then you click restore, and it will calculate what it needs to change, and it will redo all those files, and it'll reboot the system, and basically whatever changes that were made which screwed up your system, as long as those changes don't exist in your home directory, that's not a problem. As I said, you can have this back up your personal data as well. It's clunky, it's cumbersome, it really is kind of beyond what the program does. You can take and put snapshots on external drives. This is the way you should use this, is just to back up the system. And this has saved my butt. I don't know how many times. Linux Mint actually has this as a default program. It's just available. I think it's just installed. You have to set it up now. It's not even, yeah, I was going to say that you had to install it, but they tell you to set this up as soon as the system is installed. So very cool program. Timeshift, and it's Rsync based. And what's really cool about keeping it on the same file system as where the operating system lives, Rsync creates, in this case, 5 different data points with different dates. And when you first run Rsync, it creates a full copy of the original system, and then every incremental update after that, it creates a link farm, essentially, is what it is. It's another directory with a bunch of links in it that go back to the original system if the file has not changed. If there's a new file or a file has been deleted in the new backup point, then that will be reflected in that backup point. But anything that hasn't changed is not copied again. It is simply linked to, which means that you can have a lot of these backup points and it doesn't take up as much space. Because the operating system itself on Linux systems can take anywhere between, if it's a small system, it can be 5 or 6 gigabytes. If it's a big system, it can be up to 15 if you have a lot of software installed. So that's what that does. It's very cool indeed. And it runs in the background, and I have it on all my machines. And it uses Rsync at its heart, unless you're running Btrfs. So the last part of this video, what I want to do is show you some things that I have written for my own backup solutions that do different things. And go ahead and clear this. And these are, I want to show you code here. Years ago, I had this available publicly. I don't anymore because I don't have a GitHub account. But you really don't need to write anything as complicated as what I'm going to show you. And I'm going to focus on the rsync commands and what they do anyway. So don't be worried about the rest, because some of these things I wrote for public consumption. They have a lot of extra code in them just for average users to deal with and that sort of thing. So what we're going to do is let's open up... let's use gedit, and I'm going to do documents, scripts, and the first one I want to show you is a simple one that I did called Syncit. Now Syncit is a piece of software that allows me to, I think that's it, right? Yep, there it is. Go. Gedit is not found because you. I'm so confused. It should be. Do we not use gedit anymore? Did they change it? We're using a different application these days? What did I do wrong there? Hold on. No, I'm not stopping this. I'm going to figure this out. What did I do wrong? It's not found. It says gedit is not installed in this system. This is Ubuntu, and it's using the GNOME desktop. What the? Okay, we'll just do it this way. Open the text editor. All right. There's the text editor. What is this text editor called? Okay, somebody who's watching this video, explain this to me. Is this no longer gedit? I'm really, really, really confused. Anyway, we're here. Let me go open something. Wow. Okay, that was... Didn't see that one coming, boys and girls. Let's go to scripts. Let's find Syncit, which is the one I wanted to show you. Okay, there we go. All right, let's full screen this. That doesn't work? Okay. F11 does not full screen this. F11 has always full screened this the text editor. Apparently that doesn't work anymore either. Okay. Back to our regularly scheduled program. That threw me for a loop, man. I have not used Ubuntu 24.04 a whole lot, and I've just been clicking on this application and never called for it from a terminal like that. Usually you can just type in gedit and it'll open it, but apparently that gedit's not here anymore. Okay, so let's look at this. SyncEdit is a script. A script to sync to local machines on SSH-enabled network. put the last digits of the local IP argument in sync directories. This is all gone, by the way. Okay, so what this basically does is it will let me transfer files over to the machine. I'm looking for the rsync commands in here. So let's get back to the top of that because I'm there. So what it'll do is figure out the machine that I'm on. Let me see, what's the... Okay, let me see how this works. Let's see. It's been so long I've forgotten how this works, kids. Okay, so we are going to declare functions and variables, and we're going to get the net IP, which is 192.168.0. The host IP is that variable which is contained in the bash environment, so it grabs that and throws that in there. No, host IP is the number that you put it in there. It's the first argument after the command. That's what that is. So the network is a 192.168.0 network, and then we put the last two digits in, and then the program does this. Transfer status, exit script if transfer fails. If there is anything in, target host not available on network, try again. Okay, so now we're going to start syncing. And the first directory we're going to do is Ben. So echo on a new line, syncing Ben. That's what that does. So we use rsync AV delete home. And then it puts the username in there from the environment, which is Joe. And then it grabs Ben, which is in the local directory. That's in my local home directory. And then the net address, and then it puts the host IP at the end, and that's how we get the command, which I showed you earlier. And as you can see, it does the same thing. It takes the contents of the local bin and puts it on bin on the machine that we're syncing to. And then it will grab this function, this transfer status here, will run to see whether it ran properly. If it did not run properly, it will target host not available on network. That means that something happened and the network failed. And so it will exit right there with a error message of 1. That's how that works. So this just repeats this same command for each individual directory. And I don't do videos because the video directory is very large, and on my laptop machines there's no room for them, so I just don't do it, but I do have it in here, and that's how this works. So I thought I was going to be all slick and go, here's how this works. I had to actually go look at my own stuff and go, wait a minute, how did that work? So let's see that in action, shall we? Let's clear that. And we're going to run sync it. I don't think there's anything to back up, so it's just going to come back and say it didn't do anything. But let's do sync it, and we'll put it in number 12. Let's see if there's any files that have changed since then. So this is going to the file server. And it's exactly what I just showed you. And you could write a very similar script. You could do exactly the same thing, and you could have it go to different machines on your network. So that machine is synced up, and it's telling me that none of the files have changed since the last time I synced it, which kind of makes sense because I haven't used this system that much in the last week. But if there were changes, we would see them go over now, wouldn't we? So the next thing that I would like to show you is another file here. And we're going to go and find sync all, because sync all is sync it on steroids. What sync all does is it goes and it figures out what machines are online, all right, and it figures out the machines that are online and then syncs to them if they're up and running. If not, it skips them. So the first thing that we have to do is verify that ifconfig is installed, because in order to obtain the IP address of the local machine, which is very important to this program, I use ifconfig. And you're probably out there going, well, what about IP? I don't like IP. I don't like the way it's laid out, and grep is way more reliable using good old ifconfig. So what we're going to do is we're going to look to see if ifconfig is installed on the machine, which ifconfig, and we're going to take the output of that and throw it into dev null so it doesn't show on the screen. This will run every time that the program runs, so I don't want it to show anything on the screen. If there is an error, if it's like, then what it'll do, if the exit code is 0, that means that it's not there. Then it will echo sync all error, the IF utility is not installed. Ubuntu and Linux Mint run sudo apt install nettools. Linux Mint comes with that, and then it will exit with a status of 1. That's if it can't find which ifconfig. So that's the first thing we have to do. Little error thing. And then the next thing we're going to do is we do transfer status, which is the same as before. This is the sync it script, except what's going to happen is now is we have to skip the local machine. So this is where ifconfig comes in. We have to determine what that machine is. All right. And then it will say that it's syncing from this machine to the others. Check for machines and sync on. So the first thing it does is it goes and it pings the local machines on the network, and if it finds them, then it will sync, and if not, it doesn't. And if it does, if it works, it will sync to the machine, and it'll tell you what it was. And then it'll run the sync it script, which is now in a function here. Okay. So there's the sync it script. This is the function for that. The function starts right here. Okay. And this is the same script we looked at before, but it just does it on each individual machine. When it's done, it just goes back and does it again on another machine. So yeah, this is what sync all does. Set net IP, and let's see. I'm trying to figure out how this works. Net IP equals 192.168.0. We've already figured that out. Now here's the command. This is why we need ifconfig, is because we are going to declare a variable which is going to be the local machine's address, and it will look for that and then output that and put that in there. So the first machine it does is big boy, and then that's this machine we're running from, and then there's host IP, transfer. There's an open one. WeWoo is a machine. That's Cindy's computer. 15 is reserved. That used to be the work machine for the radio station. But I could put another machine in there. And Music Box is the one in the music room that has I use for streaming. And so that's how it works. And when it's done, it exits. So let's go ahead and run sync all. It's not really going to do anything, but you can see it in action. Clear that. So it takes off. Apparently it found ifconfig because it's working, and it's going to do 12. Now remember, there's no data to back up here on this machine. 14 is not on the network right now, so it didn't find it. It pinged it. It wasn't there, so it moved on. 16 is on the network, and it synced that up too. That's sync all. And finally, the last thing that I would like to show you is BU. Now this was a big project for me, and this is when I was learning how to write scripts. So this is a monster program, and it's overkill for backing up stuff on my local network. But at the time I was just distributing it, you don't need this sort of sophistication to do backups, folks. You have all the tools at your disposal. But the idea behind this you take a drive and you put a partition on there that holds some Linux native file system, like it could be XFS, it could be ext4, whatever. Put it on there as long as it's Linux native. And then when you plug that drive in, the system will find that drive and create the backup directories and everything automatically. That's the idea behind this. And then once you do it again, it will create a backup as I have showed you before. All of the changes will go to the drive. And the nice thing about it is that you can have multiple machines on that drive if it's a big enough drive. So let's see what we got here. Let's go down. Yeah, I tested it on Debian 9 and up, Ubuntu 16.04 and up, and Linux Mint 18 and up. It works on everything. And away we go. We're going to declare the static variables. User is user, and host is host name. Now you're probably saying, why are you taking this variable and putting it in the local environment? Because experience, boys and girls, has taught me that if you rely too heavily on the bash environment variables, things don't tend to work. However, if before you execute the program, you create a local variable within the local bash environment that the program is running in, things tend to be way more stable. Okay, so we're going to check for less and rsync. These are two things that we need to have installed. Rsync is the heart of the program. And this is a little sleight of hand here, because you're looking at this and going, what is that? Well, what it does, and it works on Debian systems, is we run dpackage here, and it will go and see if it'll grep rsync. And if it finds it, then it will skip everything. It'll just stop and go on. It won't do anything else. But if the output has an error, like it couldn't find it, then it's going to run sudo apt install rsync, and it's going to say yes to this when it does it. So the user is just going to install it. It'll just do it automatically because it has to be there. So instead of listing a dependency, I just set it up to just install it. So some guys might get upset with that, but you have to have these programs, and less is how you would read the menu on this. So, and then the help file. I'll show you that in a bit. So this is how we find the USB drive. It checks for the drive. It checks for something plugged in. And if it can't find the drive for some reason, then it will echo BU error, no USB drive connected. Check to see that the BU drive is plugged in. Please run BU help to learn about drive setup, because you have to do that independently. I originally had written a program called XBT that would actually set the drive up for you, but then people started using them really big drives, and they have to be formatted with GPT, and they create really large file systems. That's kind of difficult to anticipate, so you don't know. So a lot of people found that to not be working unless it was a small drive like that could use the MS-DOS. What is that called? Partition table? Yes, the MS-DOS partition table. Okay, so we determine there's a drive there, and then the next thing we have to do is look for a directory on the drive, or actually a partition called BU drive. You have to create the directory, and then you have to create the partition on the drive. Hello, I'll get it straight. With some Linux native thing, and then it has to be called BU drive. If it finds that, great, it just goes on. But if it doesn't, then it comes back and says that you need to set up the drive. So assuming that it finds all that, we start loading some functions here, and the first would be for backup. And we check for privileges, and we change ownership of the drive to the local user, whoever that is, every time that we run this, to make sure that there are no permissions conflicts. Then we create machine-specific directories on the drive, and it's checking for creating the machine-specific directories, which basically looks for the host name of the computer and then creates a directory on the drive for that host name's files to live in. It checks to make sure it's there, and then if it is, it says the BU drive is ready. And let's see what this does. Could not create directory for, that's if there's a problem there. Now we run the rsync command. So we are going to echo backing up etc and home. Those two directories, as you remember in the beginning of the video, are where all of the really important settings for your machine are. So then that automatically puts that onto your drive, into your host name, whatever that is. And this is a different rsync command. First of all, we have to run it with root privileges, because if we're copying an entire home directory, we're probably copying other files from other users. If you have more than one user on the computer, you're going to be copying files from their account as well, so therefore you must do it as a root user. If not, you don't have permission to copy and move those files, so it won't let you, and it'll error out. So we are going to archive those files, and we're not using verbose here. What we're using, the H is, what it does is instead of following a symbolic link, it copies the link itself. Because we just want to copy what's on that drive, not what's mounted into that drive. And some people will do that. They'll have a symbolic link which will go to a mounted drive somewhere else on the system, like to store all their music or videos or whatever. If you do that, you're backing, that becomes cumbersome. You could leave it that way if you wanted to, and where it followed the links, but I chose to just leave the symbolic links as links, is the point. Pretty sure that's how that works. If I'm wrong, you can tell me in the comments. It's been a long time since I've looked at that code, but I believe that's what that H does. We can look at it in a moment if you want to. Let's see, delete, and then we're going to do info equals progress2, which is a different way of showing progress without showing any file names. It just shows the number of files. It's the fastest way to go, but it gives you some indication that the program is running. And we're going to check for the status of the backup and exit. If everything went good, great. Now, this is a little thing that I call the Percy patch. What is this? Well, what it is while this is running, if you should happen to type on the keyboard, that can mess things up. When you're done, all of a sudden, all of this crazy text appears. And so what this does is that anything that you type in, it doesn't appear on the screen. It's automatically thrown into the memory up to 10,000 characters, and then it just goes away. So that's because when I was testing this software, my cat walked across the keyboard several times, and I had to figure out what to do with that. And I got to thinking about it, and I was like, well, what if this is taking, like the first time you do this, if you have a lot of data, it can take hours. Well, what if somebody walks up and starts typing on the keyboard, right? This way, that doesn't matter. When it's done, it says it's all backed up. And then the next thing it does is that it syncs the drive. The sync command basically triggers the system to write all the data that is in buffers and caches to the drive. Once that is done, it is safe to remove the USB drive. You can just pull it out of the machine at that point, because all of the eject strategies that they have, eject and safely remove drive, just run a form of the sync command. You can pull it if you want to, but sometimes I go ahead and just eject it as well. I even told people that use this program to go ahead and eject the drive even afterwards, just to make double sure. And we have the accidental input during the backup. That's once again. Now what this does is it creates a timestamp in the directory to let you know when the last backup was done. So it gets rid of one if there's one there, and then replaces it. And that makes a flag file. If there are errors, it says the errors persist. Now this is the other way around. This actually has a restore function, which lets you restore data from the backup drive to the local system if you want to. And it works in reverse. That's all it does. So what I'm going to do is I'm going to go ahead and get my backup drive and plug it into this computer so we can take a look in those directories so you can see what the structure is on the output of this program. So I'm going to actually get up and find the drive and plug it in, but for you, it'll just be a blip. Alright, so I went and plugged the drive into a machine that's on the network. So what we'll do is we'll open up another terminal. And let's go ahead and full screen this. We're going to log into that machine. Okay, I'm in. We have a firmware upgrade available. I'll take care of that after the video. So what I want to do is find out where that went. So we're looking at SDA1. That's what we want to look at. So I'm going to mount this up. Mount. Get it right. What are you doing? So we're going to put it in the MNT directory, which is where you mount things that you plug into the system, just like this. So give it my super safe and super secure password. Clear the screen. And if I go to MNT and list it, we should see that drive in there, and it's BU backups. So we'll do CD BU backups. Now if I list this, you're going to see all of the machines that are backed up onto this removable drive. And you'll see we have this machine, big boy. I have one called Jody, that's my mom's. The music box machine is the one in the music room, and Wee Woo is way in the back of the house, and that's Cindy's computer. And so if I CD into big boy, and I list it here, now you will see that we have a file with a big long title on it right here. This is the file that we created that showed the last time that this was run. So if everything is successful, the system creates this flag file. Let's do the long. You can see that, yes, that's just a file. So clear, and then ls again, so you can see that. So, and then you'll also see we have an etc directory here. So this is everything out of etc on this machine the last time that I did a backup, which apparently was Saturday, August the 2nd. I usually do these physical backups like this once every month at the beginning of the month, because I am syncing to all the different machines all the time, and it is so easy to just type sync at any time and it'll go do it. Okay, and so there's the home directory on this machine. If there was more than one person in that home directory, you'd see that we'd have all the files. So let's go ahead and cd back one directory, and we're going to cd into Wee Woo, and we're going to do another ls. So the last time that I did that machine was in August as well. And if we cd into home, and if we list that, you'll see that we have Cindy's account and my account, plus lost and found, which is in the home partition on that machine. So it grabs, it will grab the entire home partition. Everything that's in home is backed up, and it makes an exact copy as Rsync does. So we're done looking at that. So what I'm going to do is, let's see, just go back to CD. Wait a minute, actually what I want to do is CD, and what did this thing say? It said it had, we logged into it and it was talking about how it had upgrades. So device has a firmware upgrade available. So let's run that and we'll fix that as we say goodbye. Want to copy the whole thing, please? That's being difficult. Let's do this over here. There we go. Why was that hard? I don't know. Okay. And then to paste that in, just center click your mouse. Use the wheel and click it down. That works as your center button. Let's see what this thing does. Well, actually, I think I need to run this as an administrator. Now let's do it. Sure, why not? Continue. Have fun. Sure, go ahead. Sure, why not? Go ahead. I don't know what I just did. Let's see if I reboot the machine. Sudo reboot. I forget through SSH you have to try that again. Okay, so we're going to wait for that machine to come back up and see if it is looking for a firmware upgrade. Hopefully that worked. I have no idea what I just did. I've done that several times, though. It's a Debian thing, apparently, is that it comes up and does that, because that machine runs on LMDE. I won't leave before I get back into the machine, just so you can see whether that did what it was supposed to do. But anyhow, you guys get the idea here. Yes, it is really very early in the morning, and I'm starting to get a little bit punchy and rambly, so I'm going to go ahead and wrap this up. If you liked the video, let me know in the comments. I really like doing these hangout videos and poking at stuff like that. Okay, it's not begging for firmware. I guess it worked. This is good. So let's go ahead and shut that down. So I really like this format of doing videos where I'm just sort of poking around and showing you guys things and doing it in sort of a live way. If this is what you like, let me know. Comments, suggestions, always welcome. Now you have a whole bunch of tools at your disposal that use the mighty Rsync. Come up with backup solutions that work for you. Have fun. And let me know what happens. Put some cool things in the comments. Let's get a conversation going. For a long time, it seems that people don't really want to talk about stuff. And let's change that. Let's talk about all kinds of things here on this channel. Really looking forward to see what we can come up with in the months and years ahead. Thank you for watching. We'll do it again soon.